Hi everyone, and welcome back to Ask Our Experts. I'm your host, Ulysses Iñiguez, and in this episode, we continue to answer questions on the topic of motor control. Joining us again today is our expert, Pramit Nandy. So let's get into it. Pramit, there are quite a few brushless DC and stepper motor applications. How complex can the programming of the stepper motor controllers or brushless motor drivers be, and where are they used?
Thank you, Ulysses. That's again a very good question. So the short answer is, it really depends. So, stepper motors are used in applications where you need precise position control. They are known for their great holding torque as well as ability to move objects in precise motion so that you can really get to the exact point, desired point where you want it to be. Applications where, like in printers, right, you need precise position control. In those cases, stepper motors are used. 3D printers also use stepper motors, and also like mirror control, mirror position control. They also use stepper motors in many cases. Now, if you think about precise position control, there are steps like stepper motor. That's why it is called stepping motor or stepper motor. It moves in steps. But in some cases, you need micro stepping. And micro stepping can be a little tricky. So you're trying to take the energy out of the motor quickly to move through intermediate steps. So there is something called as decay. So that decay energy decaying has to be done quickly. So that kind of adds a little bit of complexity in some cases. But in general, I would say there are three things which determine the complexity in stepper motors. First one is really based on hardware configuration. Second one is motor configuration. And the third one is basically your application specific requirements. Now, when it comes to, I'll address the second one first. So because it's easier, motor configuration, it could be unipolar or the bipolar motor. So unipolar motor tend to have three or four MOSFETs to control. So as opposed to a bipolar where you have to control 8 MOSFETs and you have to PWM them. So you can see that from the hardware perspective, you need more IOs to control and you need to monitor more things in a bipolar versus a unipolar. So from that perspective, bipolar can be a little bit more complicated. Now, the second item is hardware configuration. If you are using the MCU directly to control the IOs or drive the FETs, at that point, the burden is pretty much on the microcontroller. So that point, it gets a little tricky. And the decay that I told you about previously also comes into play. But if you have a motor driver after the microcontroller, which takes care of some of these things, at that point, the algorithm-wise, it's easier or less burden on the microcontroller because some of the responsibilities are shared between the motor driver and the microcontroller. Third one is what kind of things that you need from the applications perspective. Do you need microstepping? Do you need safety, functional safety, diagnostics? All those things throw in more complexity into the system. So it really depends on those three primary factors. BLDC motors, on the other hand, is not too much different. So it's again the hardware configuration, the motor configuration, and the application demand. Those are the three basic things which are going to determine the complexity. But again, there's also more algorithms, like it could be as simple as trapezoidal censored feedback, which is basically lookup table based system, or back EMF based system where it is sensorless, or something very complicated like field oriented control where you need to do advanced mathematical operation. So if you really need smooth motor control with least noise, best torque response, then you have to go ahead with FOC, which is more complicated. But if you are okay with the noise and a little bit jittery torque, you can do with a simple 6-step trapezoidal. So again, as I said, the short answer is depends. So that's what it is. So what you want is what you get.
Thank you, Pramit. That was a great walkthrough on the complexity of stepper motor controllers and BLDC motor drivers. Viewers, make sure to check out our stepper and BLDC motor driver web pages, as well as the application notes linked below for more info on this topic. And don't forget to subscribe to our YouTube channel to be the first to know when we have more insights from our experts. We'll see you next time.